Welcome you all. In this session, we'll discuss some problem based on second law of thermodynamics. The figure shows a system that undergoes a reversible cycle during which it exchanges heat with a thermal reservoir and develops 1000 kJ of work per minute. Find the magnitude and direction of QB and QC. Okay. In this problem, this is a reversible cyclic heat engine. This is a reversible cyclic heat engine. This is very important, right? This engine E exchanges heat between these three reservoirs. There are three reservoirs. One reservoir having temperature 1000 Kelvin, second reservoir having 300 Kelvin, and third reservoir having temperature 500 Kelvin. There are three reservoirs. This reversible cyclic heat engine exchanges heat between these three reservoirs. This engine E, 5000 kilojoule of heat per minute extracts from 1000 Kelvin reservoir. This 5000 kilojoule of heat per minute extracted, this Q amount of heat is extracted from 1000 degree Kelvin reservoir, and it develops 1000 kilojoule of work per minute, and this QB and QC amount of heat either rejected or added from this two reservoirs. So we have to find the quantity of QB and QC and direction of flow of heat, right? So in this numerical, in this question, this first key important information is this is a reversible cyclic heat. This is a reversible cyclic heat engine, right? So this is the engine E. This is the reversible cyclic heat engine. This engine E delivers W amount of work and it receives Q amount of heat from 1000 degree Kelvin, and it exchanges heat QB and QC, these two reservoirs. Then we have to find the QB and QC. In this problem, we actually don't know what is the direction of heat, because this heat engine E exchanges heat between these two reservoirs, okay, these three reservoirs. So this the direction of Q amount of heat is given in this problem, but we don't know exactly what is the direction of flow of heat, is QB and QC, right? So in this problem, we have to assume some direction. Let us assume that this QB and QC amount of heat is rejected to 300 degree Kelvin and 500 degree Kelvin reservoir respectively. That means this QB amount of heat is rejected to 300 Kelvin and this QC amount of heat is rejected to 500 degree Kelvin, right? So this is the direction of flow of heat we have assumed here. This is our assumption. If you get the value of either any of this value QB and QC is negative, then this we have to change the direction of flow of heat. Let us suppose this plus QB and plus QC amount of heat is rejected 300 Kelvin and 500 Kelvin. Okay, so after calculation, if you get this value negative, then we have to change the direction of the flow of this quantity of heat, right? So this Q amount of heat is given. This is 5000 kilojoule of heat is received from this 1000 degree Kelvin reservoir, and it delivers 1000 kilojoule per minute. Okay, as per Clausius inequality for reversible cyclic heat engine, because we know that for reversible cyclic heat engine, the Clausius inequality states that the cyclic integral of dq by t is equal to 0. Let us suppose this is equation number A. Okay, we know this equation, right? So we have to find this dq by t for all three quantity of heat flow, right? Since 5000 kilojoule of heat per minute is added to this reversible cyclic heat engine at temperature of 1000 Kelvin, therefore this can be, the sign will be of this positive. This 5000 by 1000, okay? Why this positive sign? Because this 5000 kilojoule of heat per minute is added to this heat engine, right? At temperature of 1000 degree Kelvin. This is okay, minus QB by 300. Why this minus sign? Because we have assumed that this QB amount of heat is rejected. Therefore, this has this negative sign. This is this QB by 300, and this QC amount of heat is rejected. That's why this minus sign will be there. This QC by 500. This equal to 0, right? This is equal to 0. After solving this equation, we will get 5 QB plus 3 QC is equal to 7500. Let us suppose this equation number 1. Be careful in sign. Be careful in sign. Whenever heat is added to system, the sign will be positive. Whenever heat is rejected to system, the sign will be negative. So we have assumed that this QB and QC amount of heat is rejected. Therefore, this minus sign will be there, right? And this QA amount of heat is added to this heat engine. Therefore, this positive sign is there, right? So simply we have to solve this equation, and we will get the 5 QB plus 3 QC is equal to 7500, right? This is equation number 1. As for energy balance equation, this QA amount of heat is added. This engine delivers work output W, and this QB and QC amount of heat is rejected. Therefore, this QA is equal to W plus QB plus QC, right? This QA and W are given. After putting this value, you will get this QB plus QC is equal to 4000. Let us suppose this equation number 2. This equation number 1, equation number 2, and after solving this equation 1 and 2, what you observe here, this QB is equal to minus 2250 and QC is equal to 6250, right? This QB is equal to minus 2250 kilojoule per minute and QC is equal to 6250 kilojoule per minute. So what is this significance of this negative sign? This is very important. As we have discussed earlier, we have assumed that this plus QB amount of heat is flown in downward direction. But in this problem, this sign becomes negative. Therefore, our assumption is wrong. We have to change the direction of flow of heat. So this QB amount of heat is added to heat engine. Okay, this was our assumption. Okay, we have assumed that this plus QB amount of heat is rejected to 300 degree Kelvin. But after solving this equation, we get the sign of this one is negative. Therefore, this negative sign indicates that this QB amount of heat is added to heat engine. And since there is no change in the sign of this QC, that means this QC amount of heat is rejected to 500 degree Kelvin. So, one is simply this is what we have to do. We have to change. We have to change the direction of this one. We have to change the direction of this one. Okay. So, and right. So, in this problem, basically we have used, there are two important equations. One is Clausius inequality and next one the energy balance equation. After solving using these two equations, we can able to find the QB and QC. Simply we have to assume initially, because this reversible heat engine is exchanging heat between these reservoirs, we are not sure what is the direction of flow of this heat. Therefore, initially we have to assume the direction of flow of heat. Okay. So in this problem, we have assumed that this QB and QC amount of heat is rejected to 300 Kelvin and 500 Kelvin respectively. But after solving, we find that this QB is negative. That therefore, simply we have to change the direction of QB, and there is no change in the sign of QC. Therefore, we don't have to change the direction of QC, right?